Okay, class. Today's objective is that we're going to define and apply the 7 approaches to application problem modeling. Okay? So, a major component of studying mathematics is to be able to take situations in the real world and be able to convert it into mathematical equations so that we can then make sense out of it by solving it and be able to interpret what it is really asking for in real life. That's the whole purpose of studying mathematics, is to be able to make sense out of the world, convert it into mathematical equations, that we can then quantify the situation and be able to solve it, to interpret what it really means. Okay? To do that, I'm going to give you guys 7 approaches that will help you be able to attack all application problems. Okay? So make sure you follow these approaches more carefully. All right? Here's the 7 approaches. Okay? The 7 approaches are as follow. Step 1. Anytime you do application problems, read the problem carefully so you know what it's asking for. 2. Identify the variable. ID it. What are we talking about? Okay? What is the meaning of the situation? 3. You write the equation based on whatever the English that they tell you. So based on the situation, you're going to convert the English into a mathematical equation. And then you're going to solve, okay? State what the answer is and ask yourself, does it make sense? Does the answer logically make sense? And then often you want to double check it so that it actually makes sense of the whole situation, the math is correct, it satisfies your equation. And then finally, interpret the meaning of your results in the context of each situation that you'll be solving. Okay? Now, in order for you to translate English into mathematics, you have to understand some key definitions that be able to say, oh, when that is in English, it means this in mathematics. Okay? So I'm going to show you some basic definition here that should help you decipher what kind of math symbols we're going to use when a situation arises. Okay? The symbols are as follow. Take a look at here. Okay? When you see the word is, okay, this is the same as, gives, will be, was, is equivalent to, all of these or similar wording as these are considered equals. When you hear a word like less than, fewer than, no more than, or those are like less than simple, and then vice versa. So make sure you pay attention to the wording in English for each symbols. So here's less than or equal to, sorry. So less than or equal to. Less than or equal to means less than, but with a little tiny dash under it. That means equal to. Here's greater than, and then here's greater than or equal to. Okay? So the kind of wording that you see below there help you organize this and think, process it. If they say that in English, it really means this symbol in mathematics. So we're going to refer to this sheet a lot. So in your table of content, make sure you put a star by this sheet so you know, okay, I'm going to go back to here to help me decipher what are they trying to say in the problem. Okay? Then the second most important part is called the operations. So what kind of word in English means addition or means subtraction or means multiplication or means division? And so words that means like additions are like plus, sum, increase, together, combined, more than. All of these words actually means the same thing. It really means adding the operations. So anytime you hear words in this sense right here that follow like plus, sum, increase, that already means the operation is to add. So like minus, difference, less than, fewer, find, how much more, okay? All of these are mean subtraction symbols. So that means they're meant, the operation will be subtraction, okay? And then vice versa for multiplication and for division. So make sure you study those words aligned to what it means in math. So when you see it or when you hear it, you can go, oh, that means addition. That means subtraction. Oh, that means equal. That means less than, and etc. Okay? So was it good there? Okay, here we go. Let's apply the 7 steps that we just learned. Here are the 7 steps to this real world application. Doing a couple examples so you can see how to do it. Okay? First you read, then you ID, you write the equation, you solve, you state your answer. Does it make sense? Check your answer, and then interpret your solutions in the context of the problem you're trying to solve. So I'm going to go through those 7 steps so that you can see what I'm talking about. Okay? Take a look at step 1 here. Take a look at an example here. Here we go. There it is. Finding the value of an unknown number. So here's a basic example. You have one complete sentence. It says, if 5 is added to the product of 9 and a number, the result is 19 less than the number. So if I go back to my notes, I'm going to say, okay, here we go. The first thing I'm going to do is read the problem, which I just read. So I'm going to ask, they want to find the number. Where's the number is? And that number, when 5 added to the product of 9 and that number, it should be 19 less than that number. That's the rule. That's what I'm trying to find. So now I'm going to go back to my notes. I'm going to say, okay, I read it. I understand what they want. I know what I have to do. Now let's identify the variable and then write the equation. So I'm going to go in. I'm going to say, okay, here, step 1. Let x be the number, because I don't know what it is. Something unknown. So I like a dummy variable be the number that I don't know. Then I'm going to go back and I'm going to say, okay, now that I identify the variable, I'm going to try to make sense of the whole situation and be able to write the equation. So then I'm going to go back to my problem. I'm going to say, okay, 5 is added. So notice 5 is added to the product of 9 and a number, which I don't know. The result is, so notice it said here, the result is 19 less than that number. So less than the number. So I have to satisfy the condition. So I'm going to go back and say, okay, here are some of the words here. I said 5 is added to the product of 9 and a number. The result is 19 less than the number. So I'm going to assume, I don't know what that is. What am I going to do? So guess what? You got to go back and you got to look at your chart. You're going to say, well, here it says, is added to the product. So let's go back and I say, is. What kind of symbol is is? Let's go back. What kind of symbol is? Right? So I'm going to say is. Is right here. That means equal, right? Added. Added, that means added here. Product. That means multiplication. And so I go back to my problem. I'm going to translate it. So I'm going to say 5 is added to the product of 9 and a number. That means is means equal. Added is addition. Product means multiplication of 9 and a number. So a number means I don't know. So I'm going to take 9 times some number. And since I don't know the number, we call that number x in our step 1. So on step 2 and 3 there, I'm going to actually write it. And so I'm going to say, well, 5 is added to the product of 9 and the number. So the first part of the sentence is complete. Then the second part says, the result is, is means equal, so that means it must be equal here again. 19 less than the number, so I'm going to go, less than. I don't know what that is. Let's go check our chart. So if I go back and say, less than, let's see. Less than. What operation will it be? Here we go. Less than. That must be subtraction. Right? So then I'm going to go back and I say, okay, here's the operation here. The operation less than the number. So that means 19 less than whatever number I have. So I'm going to take the number and I'm going to minus 19 from it. So here's my equation. So now I am ready to solve. To solve, all I have to do is use the techniques that you learn in Algebra 1 and be able to combine like term, isolate it, and solve. So here's what I do. I'm going to say, I want to combine the x. So this positive x, I want to move it to this side. So I'm going to take the inverse of it. So the inverse operation of positive x is subtract x. Whatever I do to the right, I have to do it to the left of the equation sign. So both of the equations are the same. They're both happy. They're balanced. When I do that, x minus x becomes 0, x minus x 0. I'm left with negative 19. 9x minus x here give me 8x. You see that? Plus 5 equals negative 19. Then I'm going to say, oh my goodness, I have to combine the number. So I'm going to take this 5 plus 5, move it over to the other side. So to do that, I'm going to take the inverse property of positive 5, which is subtract 5. So I'm going to minus 5 from both sides. When I do that, 5 plus negative 5 becomes 0. Disappeared. So I'm left with 8x, negative 19, and negative 5. They're both the same operation. Okay? So then I combine them and give you negative 24. To solve for x, I'm going to divide by 8. So now I get negative 24 equals 8. So this is step 4. Here's 2 and 3. Here's step 4 is solving the equation. And now I'm going back and say, oh, I got x equals negative 3. So I'm going to go in and going to say, okay, I solve it. I step my answer. Does it make variable sense? And then check it. So I'm going to say, well, let's see. Does this make sense? So I'm going to plug it in. I'm going to put a negative 3 here. I'm going to put a negative 3 here. 9 times negative 3 is negative 27 plus 5. Well, that's negative 22. Negative 3 minus 19 is negative 22. Indeed, they equal each other, so check. Negative 3 is the solution. Okay. So now I'm going to state my answer. I'm going to say a number that when I take 9 times the number plus 5 equals that number minus 19 will be negative 3. That's interpreting my answer. Does that make sense? So that will conclude the 7 steps to help you decipher application problem. Okay? Now let's look at a real life example here, more realistic. Okay? Here's a real life example here. Example 2. All right. Now we're trying to figure out what is the number of Olympics medals. Okay? So here's the problem. It says in the 2006 Winter Olympics in Toronto. So notice this is where the Winter Olympics took place in Italy. These are background information. The United States won 6 more medals than Norway. So notice there's 6 more than Norway. The 2 countries won a total of 44 medals. So the 2 countries won a total of 44 medals. That means United States plus Norway combined for a total of 44 medals. The question is, how many medals did each country win? So, how many medals did Norway win? How many medals did the United States win? That's what it's asking us to do. So you go back to your notes, you're going to say, okay, I finished step 1, I read it. Now I'm going to identify a row and write my equation, so 2 and 3. So I finished reading, I understand what they want. They want to know each country, where they win. Let's do my variables. So I'm going to go in, I'm going to say, okay, here we go. Let x be the number of medals Norway won, because I don't know how many medals they won. But I know that the United States will be x plus 6 more. You see that? 6 more medals than Norway. So wherever Norway win, which I don't know, I call it x, I'm going to get 6 more, and that will be the number of the United States. The 2 countries won a total of 64, so you're not sure what total is. You're going to go back and say, total, what does that mean? That means all together. So it equals. Okay? So that means that Norway, which is x, plus the United States, which is x plus 6, equals 44. So then all I got to do is combine my term. So x plus x would give me 2x down here. Bring down the positive 6. Okay? I'm going to combine the positive 6 over here so I can isolate 2x and solve. So I take the inverse of addition of 6. Then that would be negative 6. So subtract 6 from both sides. 6 minus 6 is 0. I'm left with 2x. 44 minus 6 is 38. The reason I do that is I want them to equal each other in balance. Then divide by 2 and you get 38 divided by 2, which is 19. So that means x is equal to 19. Well, what is x? X is Norway. Then, if x is Norway, the United States must be Norway x plus 6. So I take 19 plus 6, that's 25. So now I have my solution. It makes sense. It matches the data. 19 plus 25, I put those two together, I get 44, which is exactly what the medal should be. So now, step 7, I'm going to translate it. I'm going to say Norway won 19 medals, and the United States won 25 medals altogether.